Okay, welcome grade 12s to exercise 7, the last one here on 2D, 3D trig. So let's just dive straight in. Use the diagram to prove this whole thing. Now we've got two triangles. Now you've done a few of these examples already, so I'm expecting you to pause when you need to, the usual by now. So in the bottom triangle, we got a whole lot of information because we got these two sides are equal. It's an isosceles triangle, so we can work out that angle down there, that angle there if we wanted to. Okay, and then I don't know what these side lengths are going to be, but this side over here, this line segment SQ, is in both triangles. It kind of connects one triangle to the other. So perhaps, well, what it seems like we're probably going to do is use the bottom triangle to work out what SQ is, and then use that in the top triangle. Now, one little hint of where we might go as well is the top triangle is a right angle triangle. So we can just go back to our whoopsie, which one's this? SOHCAHTOA, right? We don't have to use sine rules and cos rules in the top triangle when we get there. So for the bottom one, that's theta over there. Well, that's going to be theta as well. And this angle over here, well, it's an isosceles triangle, so it should add up to 180. Well, we don't have any constants yet, so we need to add 180 to get there. We've got two thetas, so we'll have to subtract them. Let's just double check that. Theta plus theta minus 2 theta plus 180 gets us to 180. Okay, so we've got all the angles in the triangle. We've got two sides that are equal. And we can probably use perhaps the sine rule because we don't have a side angle side nice thing going here. So I'm just going to use the sine rule. And as you would have seen if you've seen the other ones, and a lot of people do this, put your unknown on the top left. Generally just makes life easier. So it's SQ over sine of the angle opposite equals, pick any side. Well, the only other side we know is this one here, x over sine the angle that's opposite it. Now, if you've done some of the examples already, we've seen this kind of 180 minus idea. So I'm going to do it in this step already and just go, well, that's sine theta. And this here we can use our cos diagram to reduce 180 minus to just sine of that angle. The angle happens to be 2 theta. So we may well break that to 2 sine theta cos theta, but I'm going to do it just yet. Let me go, SQ needs to be the subject of the formula, so I'm going to multiply both sides by sine theta over, well, sine 2 theta, we were just saying it, so let's go for it. Let's change it to sine theta cos theta. Oh, look at that. That's made life good because we can cancel out a couple of things, one term for one term. So SQ is x over 2 cos theta. And it feels like we're almost there. And then it's got tan theta, so it's almost hinting at which trig ratio we're going to use. Well, let's look in the top triangle. We're trying to work with PS. We've got alpha here as our angle. And we've got that side that's opposite alpha. And we've got this side here that is adjacent. So, well, look at that. There's our tan. So let's use that. I'm going to put that over here so we can see everything in ones and go tan of alpha is just opposite. Well, opposite is PS over adjacent QS. Now we want PS to be the subject of the formula. So I'm going to manipulate this equation here equals PS and then substitute. So SQ or QS, same thing, is that over there. So we just need to substitute that in here. X over 2 cos theta times tan alpha. Well, that's what PS is, and whoop-de-doo, that's what we're trying to find. Okay, I'll see you in the next one.